Hey there, this is going to be a video about trying to make a hand crank generator for a phone, produced at 5 volts. This thing is interesting though, because I believe this thing produces around 7 volts when I spin it up to its decent speed. Okay, so I'm just going to connect, sorry I did that off camera, but I'm just connecting the multimeter up to this thing, and that's showing around, oh, you can't see it on the camera. Look, so around like 6, all the way up to 10, it's pretty crazy. However, it's alternating current. I'm going to, and we need DC to power a phone. So I'm going to create a bridge rectifier. I did previously, I don't know if you can see this, that there were some other diodes that attached to it, but they broke off. They've broken, so I'm just going to replace them with some new, fresher diodes. Okay, and if you don't know how you make a bridge rectifier, I'll show you guys how to make a bridge rectifier with a circuit diagram. But basically, you want to, I've done this wrong. You want to get 4 diodes so that you can twist the wires in a fashion so that they are like, let me get a piece of paper so I can show you. But you want to twist them so that the diodes form in a fashion such as this, right? They connect together. These two connect together. They all connect together. And here are the points where they meet. And right, you put AC in here, AC here, and here is your negative, and here is your positive. So what this does is converts AC to positive and negative DC. It's pretty impressive. So like AC, it's kind of like a wave. Current would flow through here, so out the positive end, because it can't go this way. And then when it goes back, it comes through this way and it'll flow this way, so out the positive end. So it's a constant stream of electricity flowing this way, and the circuit would close here. So say I had like a filament bulb there, it would go through there. You can use AC filament bulbs, but it's just a diagram. Okay, it's just an example. Yeah, right, I'm going to connect these diodes up to these diodes. So, in case you don't know, on a diode, you have solid black cylinder with a piece with a band of silver that goes around in this way, and that is that band shows which way the direction of current. So the band is basically this line on the diagram, and I need to attach these two wires together. Yep, like so. Bam. Yep, that's that connected, and I need to connect these two wires together. And then I need to connect these last two wires together. Yep. So these two other prongs that go to the AC power, the AC source, which is this motor, and this is the positive, and this is the negative. I'm going to connect these. I previously connected them to a 5-volt voltage regulator. It worked very slightly. There was a lot of wasted energy, but I'm going to connect them to the multimeter. The DC buck converter, and we'll see if this works with it. So yeah, this is the AC. I'm just going to plug them into this breadboard, like so, which would mean that I need to attach wires to this thing. I shall attach to a couple of blue wires. The AC doesn't really matter what colour wires I use. There's no positive or negative, so there's no necessary way which I need to put this thing through there. And to test that this thing works, we can clip my multimeter to it. I'm going to need to clip the negative to this, which would be the negative, and the positive here. And this is a bit dodgy. I'm going to turn on my multimeter to DC voltage reading, and we'll see around 5 volts, which is decent. What amperage? So 0.03 amps. No, I need to disconnect them. My bad. Keep this on here. Yep. Now I need to attach. Oh, this goes in there. Need to attach in positive with this thing, and then negative with this thing. This thing is not gonna stay, which is really annoying. I'm sorry, I'm wandering off the screen. Right, so all I've done now, so we have the, this is what goes to the motors. The motor provides the AC current, sorry, the generator. Well, the generator really is a motor, but in reverse. Generator connects up to the diode, which is a bridge rectifier, and that goes through and produces DC from the AC, and that goes to this DC to DC buck converter, which should help me to regulate the voltage much easier. Just need to connect this up to the circuit breadboard, and I'm going to test the voltage of this thing. Hope that it actually provides constant. You guys can read that, I can't. Everything's still connected. Producing like 10 volts, which is way too much. I need much lower. That's actually increased it, made it harder to turn. Much lower. So turn it this way. It's around 7 to 8 volts. I thought I was able to control the voltage output. See, look, it jumps up so much, which is really bad for a phone. Yeah, look, it was at 5 volts. Hang on, let me turn this around to you guys. It's like 2 volts, and then 4 volts, then 10, randomly. Burst of 10. That would explode in LED. But this thing is proving much harder to turn than. Let me get a look at this. Why can I not just have it at... This is annoying. It really is. It just proves to me that the voltage regulator is so much better than this DC buck converter. Yeah, the bulb voltage regulator barely worked, but at least it worked. It did work. I'm going to connect this to positive. So this should be positive. This is middle is negative. Let's take this off there. I'm gonna connect up the negative to this thing, and yeah, so I've just connected this up to the voltage regulator instead of the thing, and I'm hoping that this produces around 5 volts. No, random burst. No, it's not. I thought it was. Maybe it wasn't with this thing. It's crazy how this thing gets harder to turn. Because it is producing constant supply of 5 volts. Okay, I'm gonna solder this to the motor, then cover it in hot glue so it doesn't break again, and then try and maybe create a crank handle. I'm not entirely sure, maybe I just have an idea. Yeah, so guys, I'm back. All I've done since last time is the voltage regulator I was using. I soldered that together onto the board, and well, I soldered everything onto the motor that produces the current. Right, so let's see if I can get this to charge on camera. Oh no. I think maybe... Oh, can't put my password on camera. Everybody will know my password. I'm going to turn off my phone for a second. Power off. And see if I'll be able to charge it when my phone is off. Alright. Nope. I'll wait for the screen and everything to turn off. See, it does kind of hurt my fingers. Oh, charge for a second. Alright guys, this is very, very dodgy, but basically what I've done is I've electrical taped it and then just zip tied it together. But it's all connected up and it should be connected to my phone. Yep, it's connected to my phone. And I'm just gonna spin this thing. This thing should rotate that, but obviously I need to hold this to keep it in the same place. Can't really get it on camera very well. Yeah, oh, there we go. Really? Nothing? Oh, there you go. Oh, damn. This is hard work. The trigger isn't overheating, good. Oh, damn. Well, proof that it does theoretically work. Did theoretically charge it. This is slipping off, which is annoying. It's just a zip tie. Does this say unloosen itself? No. This thing is producing a lot of heat and sound where some of the most of the energy is going. Oh, damn. But I don't know if we can see the voltage of this thing. I believe that's negative and this is positive. So it shows you guys. Just turn this around. So 4.9 volts.